Hi, I'm Doug, and this blog is a visual road test of a Multicomp Pro arbitrary waveform generator, courtesy of Element 14. The model number is MP750511. You can check my separate video of the unboxing. This is a gorgeous dual-channel 60 MHz waveform generator with a nice big color display screen. It includes 158 built-in waveforms, and if that isn't enough, you can store and output 32 user-generated arbitrary waveforms, and even more when using a USB memory stick. In addition to a continuous waveform mode, it has a burst mode, a sweep mode, and a modulation mode, with 14 types of modulation. It isn't just a waveform generator either. It also includes a 7-digit frequency counter, with a separate BNC input on the back. I will adjust the frequency a bit just to see it change. When generating waveforms, the separate external input frequency, the period, and the duty cycle are all displayed continuously at the bottom of the screen. I'm going to run through some applications of waveform generators and then show some neat things that this particular generator can do. Generally, waveform generators are very useful in being able to supply precisely specified waveforms to test the response and processing of any circuit. This saves a lot of setup time and eliminates uncertainty in test processes. For a specific case, I recently used a waveform generator to characterize the performance of a speaker. I programmed it to sweep a sine wave through the full audio spectrum and fed this signal through an audio amplifier to the speaker under test. The speaker output was monitored with a vibration sensor and a microphone, and you can see the rudimentary speaker I tested. The amplitude of each frequency was plotted on an oscilloscope to produce a complete Bode plot of the speaker's frequency response. You can see the response envelope is not at all flat, so this speaker has lousy performance and is not recommended as a design. I also used a waveform generator to figure out how much fuel was in a fuel tank by searching for the resonant frequencies of the air cavity in the tank. Again, sweeping frequencies, I used an audio driver to vibrate the tank and a piezo disc to detect the acoustic resonances where the signal peaked. The resonant frequency increases as the amount of air in the tank is reduced. This quick video shows a preliminary test setup with a bottle instead of a tank, partly filled with water, and a scope showing resonant peaks as the frequency sweeps. This test used a piezo disc as the exciter and another piezo disc on the other side of the bottle as a sensor. Another application I had was simply providing the master clock for an audio synthesizer when the built-in clock did not work. This allowed me to successfully test the synthesizer section of the circuit, even though its clock wasn't working. There's a separate blog about that build. Next up, let's have a look at what this generator can do. I'm using a dual-channel Multicomp Pro oscilloscope to help show the signals. Although the waveform generator itself has its own view of the waveform on each channel, the scope will help demonstrate what the signals look like when overlapped or plotted in an XY mode. Of course, the generator can generate simple sine waves, and the scope shows what they look like as XY Lissajous figures when the frequency and phase are varied. I'm always fascinated by this phenomenon. So standard waveforms are selected down here. In addition to sine waves, it does square waves, which will affect the XY plots, and triangle or ramp waves, which are also interesting in the XY plots. It does pulse waveforms, noise waveforms, arbitrary waveforms, and harmonic waveforms. Here's a quick look at one of the many modulated waveforms, just varying the modulation frequency. And here's a look at a pulse waveform. But let's have a look at some of the many built-in arbitrary waveforms. There are over 9 pages of waveforms that can be selected. The selection screen shows a useful little preview of the waveform as you scroll through the choices. Here's a stair-step waveform. Here's a cardiogram waveform. Did you ever wonder what a Dirichlet function looks like? Well, here it is. How about a concave hyperbolic cotangent? Take a look at this. Or a Chebyshev function. This is a type 2 Chebyshev function. Here's a Parsons window. This generator can even do some graphic waveforms. Here's a heart. And here's a round waveform. Here is a diamond rhombus. So we can take this concept even further with our own arbitrary waveforms. Here are 2 waveforms based on data from MISAS, one of element 14 fame. These signals combine on a dual trace scope to make a nice element 14 logo. How cool is that? Next, I want to try an arbitrary XY plot. We're going to use 2 separate arbitrary waveforms that I created, and what we get is a great E14 logo. I used the PC waveform generator software that came with the device to help preview and load arbitrary waveforms. But I will do a separate video on how to create arbitrary waveforms, since it's quite a process. So, to summarize my experience with this awesome waveform generator, it has all the features I'm looking for in a waveform generator, and the user interface is well thought out. It's easy to specify standard waveforms, and it has many esoteric capabilities to accommodate unusual requirements. It actually surpasses my expectations for the device, and I have had a lot of fun experimenting with its many powerful features. Hopefully this brief demonstration of some of those features provides some insight into its capability. Well, that's a wrap. Until next time, don't forget to go big or go home.